Hello, aspiring roboticists. Welcome to an exciting new adventure where technology meets creativity. Today, we are diving into the fascinating world of robotics by building our very own path follower robot. This journey will not only be educational but also incredibly fun and rewarding. This project is a fantastic way to learn about electronics, coding, and the magic of bringing machines to life. You'll get hands-on experience with various components and see how they come together to form a functioning robot. Imagine a robot that can navigate a path all by itself, following lines and making decisions. It's like giving life to a machine, enabling it to think and act on its own. Sounds complicated? Not at all. With the right guidance and a bit of patience, anyone can do it. With an Arduino board, some simple components, and a sprinkle of code, we'll create a robot that can amaze your friends and family. The Arduino platform is user-friendly and perfect for beginners. So, get ready to roll up your sleeves and embark on this thrilling adventure. Gather your tools, prepare your workspace, and let's dive into the world of robotics. This project is perfect for beginners. You don't need any prior experience, just a willingness to learn and explore. You will learn valuable skills that are not only useful for robotics but also for many other fields. These skills include problem solving, critical thinking, and creativity. You will learn about circuits and sensors, understanding how they work, and how to integrate them into your projects. This knowledge is fundamental in the world of electronics. You will learn about programming, writing code that will bring your robot to life. Programming is a powerful skill that opens up endless possibilities. Get ready to have some fun with your very own robot. By the end of this project, you'll have a working path follower robot and a deeper understanding of the amazing world of robotics. Let's get started. Before we begin building, let's gather the necessary components. Don't worry, most of these parts are readily available online or at your local electronics store. Here's what we'll need: an Arduino board, and the Uno is recommended, a motor driver module like the L298N, 2 DC motors with wheels, a chassis or base for the robot, an IR sensor module for line detection, a battery holder with batteries, connecting wires, and a breadboard, which is optional but helpful, and of course, jumper wires. When choosing your components, consider their quality and compatibility. Make sure the motor driver module can handle the voltage and current requirements of your motors. For the battery, a 9-volt battery pack should suffice for this project. With our components ready, let's start building the robot's body, the chassis. Think of the chassis as the skeleton of your robot, providing support and structure for all the other parts. You can use a pre-made chassis kit or get creative and build your own using materials like acrylic, wood, or even Lego. If you're using a kit, follow the provided instructions for assembly. If you're going the DIY route, make sure your chassis is sturdy enough to hold the components and allows for easy mounting of the motors and sensors. Use screws, glue, or double-sided tape to secure everything in place. Section 4. Eyes on the prize, integrating the IR sensors. In this section, we will delve into the fascinating world of infrared sensors and how they can be seamlessly integrated into our robot to enhance its navigational capabilities. Now it's time to give our robot the ability to see the path. By equipping it with IR sensors, we enable it to detect and follow a designated path with precision. We'll achieve this using IR sensors, which emit infrared light and detect the reflection to determine the presence of an object or a change in surface color. These sensors are incredibly useful in differentiating between various surfaces, making them ideal for our path-following robot. Our path-follower robot will use 2 IR sensors positioned at the front and facing downwards towards the ground. This strategic placement ensures that the sensors can accurately detect the path directly beneath the robot. The sensors should be placed close enough to distinguish between the path and the surrounding surface. This proximity is crucial for the robot to make real-time adjustments as it navigates. Connect the IR sensors to the Arduino board using jumper wires. These wires will serve as the communication bridge between the sensors and the microcontroller, allowing data to be transmitted seamlessly. Each sensor typically has 3 pins: VCC, GND, and out. Understanding the function of each pin is essential for proper integration. Connect VCC to the Arduino's 5-volt pin, GND to GND, and out to a digital pin on the Arduino. This setup ensures that the sensors receive the necessary power and can communicate their readings to the Arduino. We'll specify the pin numbers in the coding section. In the Arduino IDE, we'll write a code that reads the sensor values and makes decisions based on those readings. This code will be the brain of our robot, interpreting the data from the IR sensors and guiding the robot along the path. By carefully calibrating the sensors and fine-tuning the code, we can achieve a high level of accuracy in path following. This process involves trial and error, but with patience and precision, our robot will be able to navigate complex paths with ease. So, let's get started on integrating these IR sensors and bringing our robot to life. Section 5. The brain of the operation, Arduino programming. In this section, we will delve into the fascinating world of Arduino programming, which is the heart and soul of our path-following robot. By the end of this chapter, you'll have a solid understanding of how to program your Arduino to interact with sensors and control motors, bringing your robot to life. The Arduino board serves as the brain of our robot, controlling its every move. It processes the data received from various sensors and makes decisions based on the programmed logic. This tiny yet powerful microcontroller is what makes our robot intelligent and responsive to its environment. To bring our path follower to life, we need to program the Arduino to read data from the IR sensors and control the motors accordingly. The IR sensors will detect the path, and the Arduino will process this information to guide the robot along the desired route. This involves writing a code that reads sensor inputs and sends appropriate signals to the motors. First, download and install the Arduino IDE, which stands for Integrated Development Environment, from the official Arduino website. The Arduino IDE is a user-friendly platform that allows you to write, compile, and upload code to your Arduino board. It's available for Windows, macOS, and Linux, making it accessible to everyone. Once installed, connect your Arduino board to your computer using a USB cable. This connection not only powers the Arduino but also allows you to upload your code to the board. Ensure that the correct board and port are selected in the Arduino IDE to establish a successful connection. Here's a simple code to get you started. This code will serve as the foundation for our path-following robot. We'll define the pins connected to the motors and sensors, set up the necessary configurations, and write the logic to control the robot's movements based on sensor readings. Arduino / define motor pins const int motor 1 pin 1 equals sign 5. These pins are connected to the motor driver, which controls the direction and speed of the motors. By defining these pins, we can easily reference them in our code. Const int motor 1 pin 2 equals sign 6. Similarly, we define the other pins connected to the motor driver. This helps in organizing our code and makes it easier to understand and modify. Const int motor 2, pin 1 equals sign 9, the second motor is connected to these pins. By defining all motor pins at the beginning, we ensure that our code is clean and well structured. Const int motor 2, pin 2, equals sign 10. Now that we have defined the motor pins, we can move on to defining the sensor pins. These pins will be used to read the sensor values and make decisions based on the readings. / define IR sensor pins, const int left sensor pin equals sign 2. The left sensor is connected to pin 2. This sensor will detect the presence of the path on the left side of the robot. Const int right sensor pin equals sign 3. The right sensor is connected to pin 3. This sensor will detect the presence of the path on the right side of the robot. Void setup / set motor pins as output pin mode, motor 1 pin 1 output, pin mode, motor 1 pin 2 output, pin mode, motor 2 pin 1 output, pin mode, motor 2 pin 2 output. Setting the motor pins as output ensures that we can send signals to the motors to control their direction and speed. / set IR sensor pins as input pin mode, left sensor pin input, pin mode, right sensor pin input, / start serial communication serial.begin 9600. Setting the sensor pins as input allows us to read the values from the sensors. Starting serial communication helps in debugging by allowing us to print sensor values to the serial monitor. The setup function runs once when the Arduino is powered on or reset. It initializes the motor and sensor pins and sets up serial communication. Void loop. The loop function runs continuously, allowing the Arduino to constantly read sensor values and control the motors based on the readings. / read sensor values int left sensor value equals sign digital red left sensor pin. Int right sensor value equals sign digital red right sensor pin. Reading the sensor values gives us the current state of the path. These values will be used to determine the robot's movements. / control motors based on sensor readings if left sensor value equals sign 0 and right sensor value equals sign 1. / move forward. If the left sensor detects the path and the right sensor does not, the robot moves forward. This condition ensures that the robot stays on the path. Else if left sensor value =1 and then right sensor value =0 / turn left. If the left sensor does not detect the path and the right sensor does, the robot turns left. This helps the robot correct its course and stay on the path. Else if left sensor value =0 and right sensor value =0 / turn right. Else, if both sensors do not detect the path, the robot turns right. This condition ensures that the robot can navigate sharp turns and stay on the path. / stop motors. If both sensors detect the path, the robot stops. This condition ensures that the robot does not move off the path. The loop function continuously checks the sensor values and controls the motors based on the readings. This allows the robot to navigate the path autonomously. / motor control functions void move forward. The move forward function contains the code to move both motors forward. This function is called when the robot needs to move forward. / code to move both motors forward. Void turn left. The turn left function contains the code to turn the robot left. This function is called when the robot needs to turn left. / code to turn left. Void turn right. The turn right function contains the code to turn the robot right. This function is called when the robot needs to turn right. / code to turn right. Void stop motors. The stop motors function contains the code to stop both motors. This function is called when the robot needs to stop. / code to stop both motors. These motor control functions are essential for the robot's movement. By defining these functions, we can easily control the robot's movements based on the sensor readings. This code defines the motor and sensor pins, reads the sensor values in the loop function, and controls the motors based on the readings. The logic is simple yet effective, allowing the robot to navigate the path autonomously. You'll need to fill in the specific code for motor control functions like move forward, turn left, turn right, and stop motors based on your motor driver module's specifications. Each motor driver module may have different requirements, so refer to the datasheet or documentation for the correct code. With this foundational code, you can start experimenting and adding more features to your robot. You can add more sensors, implement more complex algorithms, and even integrate wireless communication for remote control. The possibilities are endless with Arduino programming. Remember, practice makes perfect. The more you experiment and tinker with your Arduino, the more proficient you'll become. Happy coding! Happy.